positive y direction. To pull it up, what is the normal force acting on a block? So let's draw a picture. So let's say this is the 25 kilogram block, and there an upward tension force that acted on the block to lift it up. And that tension force is 135 Newton. Can we calculate the normal force? Well, we need to draw a free body diagram. We need to identify all forces acting on block. So we have the weight force, which is mg, and also there is the force that the ground exerts on the block, and that is the upward normal force. So the net force in the y direction is the sum of these three factors. We have an upward normal force, so that going to be positive and upward tension, and as well, and the weight force in the negative y direction, so it is negative mg. Now it is good to determine what the weight force is, because if the tension force exceeds the weight force, the block will not longer be on the surface. It is actually going to fit off from the surface, and there is not to be any normal force. However, there will be a normal force if the tension is less than the weight force. So let's calculate the weight force. The weight is mg. It is the mass, which is 25 times the gravitational acceleration of 9.8 meter per second square, as 25 times 10, 9.8 is 245 newtons. So notice that the tension force is less than the weight force, so there is the normal force in this problem. So let's go ahead and calculate the normal force. Now, because the tension force is less than the weight force, the block remains at rest, which means the net force in the y direction is 0. So 0 is equal to Fn. So if I am going to move T from the right side to the left side, and the same things with the negative mg. So negative mg is on the right side, but on the left is going to be positive mg, and it is positive on the right side, so it is negative on the left. So the normal force in this example is the difference between the weight force and the tension force. Now we can know the weight force is 245 newtons. It is 25 times 9.8 minus the tension force of 135. That will give us the normal force of 110 newtons. So in this case, answer choice A is the right answer. Number 15, final position. Accra is currently located 350 meters west of the town XYZ. At this instant, it is traveling east at 25 meters per second with the constant acceleration of 3 meters per second square in the positive x direction. What will be the position of the car relative to town Z after 12 seconds? So let's say this block represent the car, and let's say here is the town And let's say here is the town XYZ. So town XYZ on the x-axis will be position 0. The car is currently located at position of negative 350 meters because it is 350 meters west of the town XYZ. Our goal is to calculate the final position of the car after 12 seconds. It could be at position A, it could be at B, could be at C, or it could be at D. We have to find out where the car will be relative to town X, Y, Z. So what equation can we use in this example? Displacement is equal to the initial speed multiplied by the times plus 1/2 t squared. Now the displacement is also equal to the final position minus the initial position. So we therefore have this equation. So the final position is equal to, I am going to move this the right side, so it is going to be equal to the initial position plus the initial velocity multiplied by the time plus 1/2 at squared. This is the equation that you want to use to calculate the final position of the car relative to town XYZ. So let's go ahead. So let's go ahead and plug everything in the initial position. The negative 350, the initial velocity of the car is 25 meters per second square, and it is going to be traveling for 12 seconds. And the acceleration in the x direction is positive 3, and t is still 12. So this will give us the final answer. So all you got to do is plug this in your calculator exactly the way you see it is, and this will give you positive 160 meters. So the car should somewhere in this, it is 160 meters to the right of town XYZ after 12 seconds. So D is the right answer, number 6. Number 16. A pole is kicked at 25 meters per second from the ground at launch angle of 20 degrees. What other launch angle will yield the same range at 25 meters per second? So how can we find the answer? Well, this is one of those problems where you just have to know how to do it. The range will be the same when the two launch angles added up to 90. So to find the answer, it is 90 minus 20, so it is going to be 70. So C is the right answer, so 10-degree launch angle will have. The same range as an 80-degree launch angle because 10 plus added to 90, a 30-degree launch angle will have the same range as 60-degree launch angle, and 40-degree angle will have the same range as the 50-degree launch angle and be the way. Make sure you know this maximum range occurs at the launch angle of 45 degrees. So that will give you a max range of any projectile whenever it is launched at that angle. 17. How much work is required to speed up 10 kilogram block from rest to 16 meter per second? So how can we find the answer for this problem? Well, there are different ways you can do it. One way is to use the equation work is equal to the change and the kinetic energy of the object. The change kinetic energy is the difference between the kinetic energy of the object and the initial kinetic energy of the object. Now the object or the block was initially at rest, so the initial kinetic energy is 0. So the work is simply equal to the final kinetic energy, which is 1/2 mv squared. So it is 1/2 times a mass of 10 multiplied by final speed of 60 meters per second square. Half of 10 is 5. And 5 times 16 squared is 1280 joules. So therefore, E is the right answer. Number 18. How much work required to fill 15 kilogram rock 12 meters above the ground? So let's say this is the work and we want to lift it up 12 meters above the ground. How much energy or how much work is required to lift it? Up work required to lift something up at constant speed is equal to the change in the potential energy of the object. So work is equal to mg times the change in height. So the mass is 15 kilograms. G is 9.8 and the change the height is 12 meters. It's simply 15 times 9.8 times 12. So the work required is 1764 joules. So that all you got to do for this problem. So be the right answer. 19. Which of the following statement is associated with Newton's third law of translation of motion is to be A, B, C, D, or E? Let's look at answer choice. On an object at rest, we remain at rest unless acted on by net force. Will that associated with the Newton's first law of motion? Not this his third law of motion. So is out answer choice B says the acceleration of an object is directly proportional to net of force acting on it. That a true statement and it is associated with this second law. Third law, so B is out. So this equation is associated with the Newton's second law of motion. The net force is mass times acceleration. So if you increase that net force acting on an object and the mass is held constant, the acceleration will increase directly. So acceleration and net force are directly proportional to each other. Now, if you increase the mass of the object while keeping the net force for the same, the acceleration will decrease. So mass and acceleration are inversely related, and that the basic idea obtained behind Newton's second law of motion. Now, what about answer? Choice C, the net force acting on an object is equal to the rate of change of the momentum of the object. Now, this too is related to Newton's second law of motion. So let's start with the equation net force is mass times acceleration. Acceleration is equal to the change in velocity divided by the change in the time. It is v final minus v initial over t. So therefore, the net force is mass times the change in the velocity divided by the change in the momentum is mass times velocity. So mass times the change in velocity represent the change in momentum. So the change in momentum divided by time is equal to the net force of the object. So this too is related to Newton's second law of motion. Now what about D? An object at rest, or rather an object in a motion, will continue in motion unless acted on by net force that is stated with the net Newton first law of motion. So by elimination, the answer has to be E. For every acting force, there is an equal and opposite reaction. Force which acted not on the same object but on the different objects. So let's say is the action force, the reaction force is going to be equal to the action force, but it is going to be opposite in direction. So if one is a positive, the direct other is a negative. Number 20, in which of the following equations represent acceleration of the two blocks? The system shown below. Now there no friction in this problem. There it is friction on the horizontal surface, and there no friction between the rope and the pulley. Now we are gonna guard the interior of the pulley, so we are just assume the pulley has no mass. It is massless pulley. How can we calculate the acceleration of the system? I am going to show you two ways, a quick and simple ways in case you have multiple choice test. But for those how have free response test, I am going to show you another way in which you can calculate the acceleration by drawing a free body diagram. So there, the easily method based on second law of motion. We know the net force is the mass times acceleration. So acceleration is net force divided by mass. Now there is only one dividing force for this whole system, and that is the weight force of plug 2. The weight of plug 2 causes the entire system to move in this direction. And so that way force is the mass of plug 2 times 9. So it is M2G. And then you got to divide it by the total mass of the system, that 1 meter, meter 1 plus meter 2. So that going to give you the acceleration of the system, which answer choice B. So B is the final answer. So now let's get the same equation using free body diagram. So I am going to erase everything. So if you need to go back to this point, the video, just rewind it. So here is M2 and this is the M1. So let's focus on mass 2. We have downward weight force, which is M2G. An upward tension force, which we'll call T2, that net force acting on block 2. That in the y direction and is equal to the upward tension force, which is going to be positive T12, since it is going to positive y direction, and this is going to be negative M2G because it is going to negative y direction. Now the net force is mass time acceleration, and now we can call it y, but the acceleration acted on block 2 is the same as the acceleration acting on block 1. Now this acceleration through it has to be negative because it is going in the negative y direction. So the net force in the direction is negative m because that net force has to be negative. So let isolate T2 in this example. So let's take this term and move it to the side. So T2 is going to be M2G minus this support. Now Fk, we can replace that with the Mu K times the normal force. Now the normal force has to be equal to the weight force because the net force in the y direction. The y direction is 0, so we can replace Fn with mg. So therefore we could cancel the mass on both sides. And so the acceleration of this box is negative muk times g. The acceleration is negative because the box is slowing down to rest. It is decreasing. So the acceleration is going to be negative. Mu k is 0.15 multiplied by the gravitational acceleration of 9.8 meters per second square. So the acceleration is negative 1.47 meter per second square. So now we can use the kinematics to calculate the displacement. We know the initial speed is 12. And because the box comes to rest, the final speed has to be 0. So we can use this equation. V final square is equal to V final square plus 2 d the final 0. The initial velocity is positive 12. The acceleration is negative 1.47. And now we can calculate d, and let's not forget to square this number, and 12 square is 144, and 2 times negative 1.47. That negative 294 times. So d in the move to terms to the left becomes a positive. So we have positive 2.94. D is the equal to 144. So 144 divided by 2.94, that will give us the displacement, which is 49 meters. So that how far the box will travel before coming to rest. So B is the right answer. Number 23, 2 kilograms ball attached to 1.5 meter long spring moves horizontal circle at 15 meter per second. What is the tension in this string? So let's draw a picture. So here the string, and here's the ball, and it is moves in nearly horizontal circle. Now this is the tension. in the strings. Now we do have the weight force of the pole, which we need to take into consideration, and the tension has an X component and it has a Y components. And there the angle theta, if the pole is moving very fast, Ty will be insufficient. So the tension in the string is approximately equal to Tx. Now notice that Tx points toward the center of the circle, so Tx provide the centripetal force. So Ty is equal to mg and Tx is equal to the centripetal force, which is mv squared divided by T. And once we find Cx and Ty, we can calculate it T. So let's start with the Ty. The mass of the pole is 2 kilograms and G is 9.8. So Ty is 19.6 newtons. So that the first things we need to do. Now let's calculate Tx. So we have mass of 2, the speed of the pole is 5 meters per second, and the radius of the circle is the length of the string, which is 1.5. So Tx, I am running out of the space. Here is 300 newtons. So now we can find T. Notice that this forms a right triangle. So T is the square root of Tx squared plus Ty squared. So that is going to be the square root of 300 square plus 19.6 square. So T is 300.6 newtons. So as we can see, T and Tx there are very close to each other. But the exact answer is answer to choice D. We could round that to 301. It is a little bit higher than Tx, but not by that much. 24. What is the maximum speed at which a car can safely round a curve radius 400 meters? So let's say this is the curve that the car is traveling. It is making a turn, and to make this turn, it is need to extra centripetal. To make this run needs to extra centripetal force, which is directed toward the center of the circle. Now, what provides the centripetal force in this particular example? We see that when a pole travels around a circle through a rope, tension provides centripetal force. Tension in the rope because the pole turns in this case. In static friction between the tires and the rod allow the car to turn. So static friction provides the central force in this example. So what we need to do is set static friction equal to the centripetal force. Static friction is MUS times the normal force. Now, static friction is an inequality. It can exist from 0 up to the maximum value, which is mu s times the normal force, and we need to use the maximum value because we are looking for the maximum speed. The central force is mv square over t. It is mass times the center force acceleration. The normal force is mg. Since the surface is flat and we could cancel m, now we need to isolate v. So let's multiply both side by t by r. So this will cancel, and so v square is equal to mvs times rg. So the maximum speed is going to be the square root of mu times the radius times 9. In this example, mus is the radius 40, 100, and g is 9.8. So the maximum speed is 28 meter per second. So therefore, C is the right answer, 25. Which of the following statement is not true concerning a ball that runs straight upward into the air? So let's draw a picture. So the ball goes up and then it goes back down. Let's call this point A, point B, and point C. So let's look at each statement. Answer choice. A says the speed of the ball is decreasing as the ball travels upward, and that true or false. That is a true statement. We are looking for the false statement. And B says that speed of the ball increasing as travel down. That is true. Whenever an object moves away from the ground, the speed decreases. And whenever it moves toward the ground, the speed will increase. But let's understand why whenever the acceleration and the velocity vectors have the same sign. That is, if they are pointing in the same direction, the object will be speed up. So if the acceleration and velocity are both positive, or if they are both negative, the speed will increase. Now the object will slow down. If the acceleration and velocity vector have different sides, either they are both positive and negative or negative and positive. So if the signs are different, it is going to be slowing down. So let's analyze the first part of the trip. So from A to B, when the ball is going up, the acceleration is negative because gravitational acceleration is always down AY. The acceleration in the Y direction is negative 9.8 meter per second. Brings things down, so the acceleration of the left side and the right side will always be negative. Now, what about the velocity in the first half? The ball is moving upward, so the velocity is positive, and during the second half of the trip, it is moving downwards, so the velocity is negative. So during the first half, notice that the acceleration and velocity vector are different. So in the first half, the object is always down, the speed decreasing. So A is the true, the speed of the pole is decreasing as the pole travels toward, because the acceleration is negative, but the velocity is positive. Now for the second half of the trip, the acceleration and the velocity have the same sign, and so the speed is going to be increasing. It is going to be moving faster. And so B is the true, but the speed of the ball increasing as the ball travels downward. Now, what about C? The velocity of the ball is zero at the maximum height, and that is in order for the velocity to change from positive value to a negative value, it has crossed zero. Let's say a positive 5, and you want to get a negative there, and you can't skip a number, you have to go, and that going to occur at point B. The velocity is zero now because the ball is thrown straight up there, only vertical speed, meaning everything. When I went talk about V, it is really Vy. There is no Vx in this problem. It is not moving in horizontal direction. It is completely moving the vertical direction, and the top of the vertical speed is zero, and because there is no x component, and we can say therefore the speed is zero. If Vx is zero, then V becomes the square root of Vy square. So V equals Vy when they are now horizontal component. So C is the true statement. Now, what about D and E? Say the velocity of the pole is decreasing as the pole travel upward. And E say the velocity is increasing as the pole travel downward. So which statement is true? It is D or E, and which one is a false? Let's redraw this picture now. Before we do that, we need to understand